Okay, welcome class to our correction of question number 5 from my recent redox assessment, quiz, test, whatever you'd like to call it. And these are the acidic aqueous problems that can be a little difficult, but I think as we walk through this you'll see how to work this through. Alright, so we start off with this equation here. We have dichromate with a -2 charge plus iodine to make chromium plus 3s and iodate negatively charged. Important to remember to put those charges on the things that have an overall ionic charge. Remember, all elements are 0, so you could put a 0 above that iodine. All right, now again, as we talked about, we have to have an oxidation and a reduction in all of these, so we're going to go ahead and do that. The oxidizing is going to be the iodine going from 0 to the iodate. The reduction is the dichromate going to chromium 3. And again, I have sometimes put the 3 plus or the plus 3 as long as you know that it's charged. I should officially put it that way. All right, now as we go through these, we know that first thing you should do is balance elements. So I'm going to put a 2 in front of that iodate and put a 2 in front of that chromium. Now the next thing would be get the oxygens balanced using water. So we'll need to do a little bit of rearranging here. I'm going to go to the next page to give ourselves a little bit of space. So again, we're going to have over here iodine going to the iodates, now that I've balanced the iodines, and we have the chromiums going to the chromium 3. Alright, so we'll need 3 waters on this left-hand side. And we will need, I might as well do the waters for the bottom as well. We're going to need 7 waters on this side. All right, I'm going to probably squeeze a couple things in here just for the space of the screen that I have. Now we need to make sure that the hydrogens are balanced. So since I have 6 hydrogens over here, I'm going to be adding some extra hydrogens over here. Need to go back, but I can do that nicely with this Doceri program. It'd be nice if my waters were balanced. This over here should be 6 waters because of the 3 times 2 oxygens, so 6 there. And now that gives me 12 hydrogen ions over here. And down here, again, we would need 7 waters. I'll rewrite that back in, which gives us 14 hydrogen ions over here. All right. Last thing to do is the electrons. Now, this is the tricky part on this one. So we have a total of 2 negatives and 10 positives on this side. So we need to get that back to 0. So I'm going to try to squeeze it in, 10 electrons over here. Okay. And on the other side, here we have, if I'm looking at 14 positives and 2 negatives, and I have a total of 6 positives on the right-hand side for chromium. That gives me plus 6 on the right-hand side for the chromium and plus 12. So I need 6 electrons on the left-hand side over here. All right, now I multiply through. It looks to me like I have a common of 10 electrons, well, at least 10 electrons on the right side for the first equation, 6 electrons on the left side of the chromium on the reduction equation. So my common number there is 30. Some people make the mistake of thinking it's 60, and then you'll end up doubling everything. So ends up, I'm going to take this entire equation here, and again, I know I'm running out of room. This whole thing up top is going to be multiplied through by 3. And this down here is going to be multiplied through by 5. That might not seem obvious to everybody. That's the deal. All right. Now, instead of multiplying through with the screen size I have here, I'm just going to start canceling. And here we have 3 times 10 is the 30 electrons. So again, electrons always have to cancel out. Here, 5 times 6 is 30 electrons. Okay. There are some hydrogens that end up canceling out here because I end up having 5 times 14 or 70 hydrogens on this side and 36 on the other side up top. So that'll end up reducing down to 34 hydrogens. So again, I'm canceling out pretty much all of these hydrogens here. But remember, because of this 3, that's 36 hydrogens. And then since I have a 5 over here, 5 times 14 would give me, again, 70. So some of these hydrogens cancel out, and really I'm left with my 34. You could keep that total here if you wanted to, or just bring it down. I'm going to bring it down. All right. I'm starting to bring down everything now. So 3 times my iodines, that comes down. I end up having 5 times my chromiums. Again, maybe still don't want to forget that -2 charge. I almost forgot it myself. And I think that takes care of your left side. Now we're going to go to the right side, and we have multiplying through again 6 IO3s, and we have 5 times 2, 5 times 2, or 10 CR. And our waters, we have 18 waters on the left and 35 waters on the right. So again, we should cancel out. I probably should have done that before. All the waters on the left-hand side cancel out, and we're left with 17 waters on the right. That, if you check through, should be the balanced acidic aqueous reaction for this. Hope that helps. Have fun correcting.